Welcome to another episode of the .NET Show. Now, in this world of web browsers and web applications and HTML and web authoring tools and stuff like that, sometimes it's easy to lose track of what a real application used to be like. Well, fortunately, the .NET framework actually allows us to get back to our roots. We can take and actually write a smart application, a true Win32 app that's running on the client system that has some additional functionalities that gets pretty close to some of the extended capabilities that a lot of people really like out of web applications. In today's episode, we're going to look closely at what the .NET framework allows us to do with a traditional application, but with a new programming model. But before we do that, let's check in with Erica in the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. On August 24th, Microsoft released to manufacturing its latest operating system, Windows XP. Windows XP is built on an enhanced Windows 2000 codebase with different versions aimed at home users and business users, Windows XP Home Edition and Windows XP Professional. New features include support for side-by-side assemblies, isolated applications, and publisher and application configuration. Windows XP will be in stores on October 25th. On September 4th, Microsoft announced the release of Windows XP Embedded Beta 2. Windows XP Embedded, the componentized version of Windows XP Professional, is designed to enable rapid development of reliable, full-featured embedded devices. With more than 10,000 individually selectable components and a new set of end-to-end development tools, Windows XP Embedded will enable developers to build a broad range of rich devices, including retail point-of-sale devices, thin clients, and consumer devices such as set-top boxes. Through the Technology Preview program, developers can begin evaluating the latest Windows technologies and prototype designs based on Windows XP Embedded Beta 2. On November 6th or 8th, Microsoft Developer Days 2001 will be held in 32 cities in the U.S. Dev Days 2001 will allow developers to get first-hand insights on .NET development using the very latest tools and technologies and see how Visual Studio.NET simplifies the creation of XML web services and .NET applications. Check out the Dev Days website to find out which of the 2 days this event will be happening in a city near you. In early September, Microsoft announced .NET My Services as the formal name for the user-centric web services previously codenamed Hailstorm. The .NET My Services are best thought of as building block services that enable individuals to access and to programmatically share commonly used personal information, such as their calendar or contacts. With these services, users can access their information anytime, anywhere, from any device. Developers who attend this year's PDC in October will be the first to receive early .NET My Services code. Be sure to check out the show transcript for links to more information on these news items. And that's been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Now, today we're going to talk about how to write an application for the .NET framework. And by application, I don't necessarily mean some of those web applications some of you guys hear about. Instead, this is a real Windows side web application. And here to discuss those issues with me and share some information on how you can develop those apps, I have Jamie Kuhl, Program Manager, and Mark Boulter, another Program Manager from the .NET Framework Group, to discuss Windows applications and what the new world is like. Now, a lot of the shows I've had so far have been talking about, web functionality, and people are talking about new technologies nowadays. How web applications, HTML pages, and web pages, something like that. And quite frankly, I mean, what we talk about resonates really well with people out in the audience. Exactly, why do you think web pages and web applications have so much stickiness to these people?
Well, I guess one of the big things building a web-based application that renders itself as HTML pages is that it solves the deployment issues people have with applications today.
What deployment issues, what do you mean by that?
So it's very much easier to build a web application where you just put the HTML pages up on the web server, and then when the user navigates to a URL in the browser, those web pages just download onto their client. There's no need for an explicit install step if the application needs to be updated, you can simply update it on the web server, and then the next time the user navigates to that web page, they get the new version of the application without having to distribute it across a whole set of clients. It just kind of rolls onto the client automatically as it's used.
So no need to send CDs or floppy disks out, or send email to people says, oh, you need to go download this new version, junk like that. They just see it.
Yeah, it just happens when they navigate. When the next time they use the application, they just get the new version of it.
Yeah, it's almost, it's kind of fun sometimes. You got a website you constantly go into, whether it's, Microsoft.com or something like that, and every few months they do some sort of big redesign on it. You got this new UI and stuff like that. There's new features and functionalities to it. So you're kind of saying that's a cool feature from a deployment standpoint.
Yeah, I think that if you look at a corporate environment, having a mechanism that allows you to roll out a new version of an application in response to a change in the business very quickly and easily is fundamentally important. I think the other thing that is very attractive about that model is that each application is isolated from the other applications. There isn't any interaction between the web pages from a point of view of, well, if I use this website here, when I navigate to this website here, something breaks in the first website, which is one of the things you see is one of the things that's difficult to solve with Windows applications today. We coin this phrase to describe it, DLL hell.
Well, I mean, that's because you've got these different applications all using trying to use the same DLL, and one application updates DLL and it doesn't. Well, web pages aren't DLLs though. It's just information you're viewing on the
that's
web.
right. I mean, but that's one of the fundamentally attractive things about it, is that you don't end up with one application updating a shared component and in the process of doing so breaking another application that was also using the old version of that shared component.
Mm-hmm. But I mean, we've been dealing with web applications for 6 years now almost, and I mean, it's almost hard to get away from it. And it seems like every day I turn around, some new web application, even inside Microsoft, another group has added some ordering process and stuff like that onto it. Myself, I'm a Win32 programmer. I came up from writing real code like that. And while doing web pages is fun. Yeah. One of the problems I run into is that it's almost like this little brick wall. That every once in a while there's certain things I just can't do with a web application. I really want to get down to writing some binary code that gets to some additional functionality of Windows itself, and not just HTML browser stuff.
So I mean, that's one of the trade-offs you have to make. You get this easy deployment model and the isolation model, but at the same time there are features on the client that you can't take advantage of because you're limited to what you can do with HTML and script. You're also limited in terms of interactivity, so it's much harder to build an HTML-based application that's highly interactive, that responds very quickly to the user interacting with the application. Typically you get a round trip back to the server to refresh the page.
And even beyond just the pure UI things, there's just certain things you can't do either from a security reason inside of the browser or from a practicality standpoint on the server that you can do in a client app, right? Peer-to-peer is a big thing people are talking about lately, right? And to do that, you pretty much have to be running code on the client to be able to talk to it. You certainly can't run a peer-to-peer app on the server. There's other things along those same lines where you just need to be you need to be on the client to be able to do them.
I know, quite often we refer to that as a smart client. We're telling people you're running a dumb client or a thin client where you just got a browser going on, everything's coming from the server. Smart client applications where you're actually installing bits on the client that can take advantage of some of the processing power, whether you're trying to do some calculations, stuff like that, or actually accessing some of the deep user interface features or the file system or the network system or something like that. Yeah. So what exactly are we doing from a smart client standpoint with the framework to increase this ability?
So there are a number of things we're doing. I think the fundamental thing we're doing is to really fix the deployment issues that people have today. So the first thing that we addressed is application isolation. So with the .NET framework, the default model when you build an application with shared components is to distribute that application with its own private version of those components. So now when I install an application onto the client machine, it puts those components into the bin directory for that application. When the application runs, it finds those components in that bin directory. When you install another application, it installs its own version of those components, and when it executes, it finds its components out of its bin directory, and so the two applications are isolated from each other. So you can install multiple applications onto the client, and you don't get this interaction between shared components.
This is that what we call side-by-side execution or something like that?
Yes, that's right.
And that's part of Windows XP, or is that part of the .NET Framework?
Well, so there's work that's happened in Windows XP, but it's fundamentally part of the .NET Framework and building managed code. So when you build managed code and you distribute that application to a client, whether the client's Windows XP or Windows NT4 or Windows 2000, you get those same benefits.
Mm-hmm. Now, when you said you manage code, that's a new term coming up in the conversation. And managed code means what exactly?
It means code that's written that targets the .NET Framework and the Common Language Runtime. So it's code that you write in a language that targets the .NET Framework.
Mm-hmm. Now, we've talked about a couple of previous episodes when we talked about the .NET Framework, and that basically allows the code to keep track of memory and pointers and issues like that better, so that you're not writing memory leaks and other stuff like that.
That's right. It means that instead of having to spend a lot of your kind of application design time thinking about memory management and pointers and buffer overflows and those kind of things, you can just focus on writing the code that's important to you and solving the business problem you want to solve, rather than having to solve a whole load of technical issues.
It'll also let you use whatever language you want when you write your application, instead of targeting one specific language. So you can write a DLL in one language and an exe in another language, and they can talk to each other fine. It also helps with security, to providing sandbox when code comes from certain locations and other things along those lines.
Mm-hmm. Okay, so we've talked about with the smart client applications, getting rid of the DLL problem, about managed code and making it easier to write applications that make use of memory properly and using multiple languages and stuff like that. Now, from a deployment, like we talked about web pages having this web deployment model where everything comes across, how are we addressing some of those issues?
So one of the other things we've done with the .NET Framework is to put a set of tools in place. Part of the framework is a class called assembly, and you can actually use an assembly to download code dynamically from a web server. So in much the same way that in Win32 you could use load library to load a DLL off disk dynamically using the .NET Framework, you can actually not only load assemblies which are akin to DLLs dynamically from the local hard drive, you can actually also load them over HTTP. So you can just say assembly.load from and give it an URL to an assembly, and it'll download that, and then you can dynamically use that assembly. And so that gives you the ability to start building those more web-like apps where you have an application that's dynamically downloading parts of the application from a web server. And it has the same attributes that HTML pages in the browser do, in that when you download that code, it gets stored in a download cache. The next time you go and execute the application, it goes and looks at the version in the download cache and the version on the web server. If they're the same, it just uses the one out of the download cache. If there's a new version on the web server, it automatically goes and grabs that, pulls it into the download cache on the client.
And then uses. So I mean, like to put this in web browser aspects, if I've got a page I'm downloading a bunch of images on it, I know that when the web browser loads it up, it just quickly pings the server to find out whether another image has been changed since the image it's trying to display. And if the image hasn't changed, it just uses the image it has from the cache. Yes. And if the image is modified, it downloads an image. So you're saying now, I could have an application that maybe had a bunch of components or DLLs that it comprised of, and as that application's running, if suddenly one of the DLLs was updated back on the server, I would just automatically get that code loaded down?
The next time you run the application, it will, if it's been updated on the server, it will automatically download that. So you get the best of both worlds. You get the ability to dynamically update an application on the client as you update the essential web server, but you're not soaking network bandwidth in that. You're not going and downloading that every single time you run the application, only when the applications, the parts of the application have been updated on the central web server.
Now, another concern from a web standpoint is that on web pages, if I'm not online, web pages often don't work too well. Right. So is the same, would I need to always be online in order to run one of these applications?
So in this release, you can make the application run offline. It's not as easy as we'd like it to be, but you can certainly do it. So that's one of the advantages this type of application has. And Jamie is working on a white paper that describes how to do that at the moment. So the default model is you have to be online, but you can do some more work and make the application run offline as well. So you kind of get the best of both worlds.
So what exactly is the offline experience then from that standpoint? Does it just have to pause for a while it makes sure the server's not responding, so I've got to go to the cache now, or what exactly happens there?
Basically the offline model is where we allow you to, instead of using the assembly load from mechanism that Mark described, we'll actually allow you to just copy down using HTTP again the DLL from the server to the local disk and then load that out of the local disk, again applying security the same way we would apply in the assembly load from case. But basically it requires you to do a little more work. So with assembly load from, the copy would automatically be done for you. The check to see that the latest one's already down and cached was done for you. You have to do a little bit more work to take care of some of those problems yourself. But once you've done that, you have essentially the same model where you point it off the server, storing it on the disk, and then it lets you run it offline. This, basically, in terms of moving forward with a lot of this stuff, that's definitely one of the areas we want to make better in general. Is the main thing we've focused on for this release is putting the power in the hands of the developer to make sure they can build these applications that are auto-updatable. Like if you look at all the applications today that Microsoft's producing, like Microsoft Money or MSN Messenger or Windows Media Player, even Windows XP now, they all have technology that allow them to update pieces or all of the actual application from the web somehow. So we wanted to make it so we gave the developer the pieces they needed to build those applications themselves. And what we want to do in the future is make it so that some of the work that they had to do in the past, like calling assembly load from and thinking about a lot of those problems, we take care of them for you in the runtime and in the development tool experience that we provide.
Okay, so essentially if I wanted to write such an application like this today, I would manually maybe check to see whether there's an internet connection, and then do an if statement. If there is, then do a load from. Else, just bring it off the local cache.
That's exactly right.
Okay. Now, anytime you talk about the web and the internet and running things remotely, security is something that always kind of rears its head. What exactly are some of the security concerns that we need to have on an application like this?
Well, so one of the other great things that we've done with the .NET framework and the runtime is we have this thing called code access security that controls what code is allowed to do based on where it came from. So there are a set of things called permissions that we use. So for instance, file I/O permission or UI permission that controls whether you can display a window or not. And we use those permissions to guard sensitive resources on the client machine. So for instance, when you use the .NET framework and say file open to open a file, then what we do inside that API is we actually demand the appropriate file I/O permission. So once we have this set of permissions defined, we then group those together into things called permission sets. And so you might have a permission set, for instance, which says you're allowed to display top-level windows, you're allowed to talk back to the web server you came from, but you're not allowed to access a registry or access a local hard drive, which makes an application running with that set of permissions safe. Once you have those permissions grouped together into permission sets, you can then associate those with things called code groups, and code groups is partly about where the code came from. So for instance, there's a permission set associated with each of the zones in Internet Explorer. So when you download code from the intranet, you get one set of permissions. When you download code from the internet, you get another set of permissions. And so what happens is when you download code, the runtime goes and checks to see where that code came from and gives it the set of permissions based on where it came from. So if you download a control from the internet, for instance, it can't go and walk across your hard drive looking for financial information to send to somebody it shouldn't do. One of the other things you can do is you can actually give your code a digital signature called a strong name and then associate permissions with that strong name. So you can say, for instance, well, I don't trust any code coming from the internet. I don't trust any code that's coming from anywhere on my intranet in general, but if it's signed with my strong name, if it has this unique identity, then it's something that I've written, and I'll give it permission not only to download and execute, but also to go and access the local hard drive or go and talk to this database server over here. So we have a very powerful security system that stops code from doing bad things, so that when you download code, you can do so safe in the knowledge that it's not going to do bad things on your machine.
You brought up the term strong name.
Yeah.
What exactly is a strong name?
A strong name is basically a way to sign an assembly and uniquely identify it. So the scenario that Mark was describing there basically is all on the lines of, if you go to a web server and you download an HTML page, and that HTML page itself doesn't have permission to access your local disk. Well, if you go down and download an assembly, a managed assembly from that same server, that code from that managed assembly from that same server shouldn't really be able to do anything differently than what that HTML page could do, right? If they can't access the disk, why should this code? So by default, by default, all of the security permissions for managed code follow very closely what the IE security model is. So if you know what you can and can't do in different zones in IE, that's probably the same answer for what you can and can't do in R mode. Now, the problem with that is sometimes, let's give a common example. If you wanted to do something in the local intranet zone that you wouldn't otherwise be able to do. So, for example, if you wanted to roll out an application in your internal company that requires direct access to your file system, it still isn't a permission you have access, even if it's coming from your local intranet. So you may want to give that application permission to run at higher level of security and have access to the file system. So the way you'll do that is basically still keep the default of, code coming from the internet only has, X amount of permissions, but you'll sign your application with your company's public key and thus give it a strong name based on your company's public key. And then when you deployed your operating system and .NET framework to all of your clients, what you would have done is basically configure the security policy to say, any code running that's been signed with this particular public key is allowed to run with a higher set of permissions. So that application will come down, be signed, we will see that it's signed by that public key and be allowed to run with a higher set of permissions than other code coming from the local intranet.
So is that the same sort of thing as like ActiveX controls today? If you download those, it says, hey, this ActiveX control has been signed by Microsoft Corporation, and you can trust it that one time, or say always trust things from Microsoft. That same idea as that?
Actually, it's not the same model. So the ActiveX model uses certificates. And there are pros and cons to it, but what we found is, especially in the corporate intranet case, ActiveX control security model isn't always what you want. So when an ActiveX control comes down, that dialog comes up and it asks you whether you want to trust it or not. And the problem is a lot of users don't know whether they want to trust it or not, right? They don't have enough information to really make an intelligent decision based on that. So the default is people will just say yes. And as soon as you say yes, then what happens is that ActiveX control runs with essentially a full permission, right? Just the same as an exit coming off of your box. Whereas with managed code, our model has been, since users generally aren't in the position to make an accurate trust decision, we want all of the security trust decision information to be made based on the IT department, the admin rolling out the box. So in that case, we would never pop up UI like an ActiveX control will come down. In our case, the code would come down, and we would decide whether the thing should run with higher permission or not, right? So if it's been signed by, a public key that it trusts, right, and the client's already been configured to say it trusts that public key, then it'll be given that security permission for it. It'll be given permission to do that. And that's essentially the same thing as if the user clicked yes, except it wasn't the user clicking yes. It was the user's admin making the decision for the user ahead of time.
Mm-hmm. And what about like a home user? I mean, where they don't have an IT department installing the machines for them?
So the runtime comes with a set of wizards that allow you to control that. So there's an MMC snap-in that has a set of wizards in it. So for instance, what you can do as an end user is you can go to that wizard and you can say, I want to trust this particular assembly, or I want to trust this particular website. So we've tried to make it easy for the home user to make those same kinds of decisions, but in the corporate environment, really give the decision about security policy back to the IS administrators and the security administrators who really have the knowledge to make those kind of decisions.
Mm-hmm. Okay. So then, let's say I wanted to write an application like this for this, make use of this deployment stuff, and let's say I'm a commercial application vendor, like someone's writing a picture editing program or something like that. And traditionally in the past, I've sent out CDs, had people send in orders and stuff like that. And I decided to move over to a web deployable model, so I can take and if I want to add a ping support to my photo editing thing, I can just put a component on my thing and suddenly they'd have access to it. So the users probably home users in many cases, I don't have IT access to the machine, so I can't assign their strong name acceptance stuff. What sort of hurdles am I going to be faced with to get my app to run in a fully installed mode, just as if they installed off a CD?
So if you want to do that, the simplest way to do that is to do what you do today, which is to package it up using an MSI file. But the set of for the kind of application you've described, the set of default permissions we have will probably allow that application to run. So, for instance, if you think about the kind of things a photo editing software would want to do, it would want to allow me to pull up a form that contains some kind of picture editor, well, you could do that inside the default permissions. The other thing that
but I'd also need to write out files to the disk, and so like I wouldn't.
So our file open and save dialogues have what we call a safe mode, where you can programmatically display the file open dialog to the user, and the user can go and select a file, and then what you get back is not the file name itself, because that's dangerous information for you to have, but you get back the stream of bits that the file contained. So the reason that's safe is because there's a user interaction involved there. So in order to have the user give you this file to edit, they have to actually you have to display the file open dialog, and the user has to go and pick the file. So the user's in control of what file gets selected. Mm-hmm. And the same with file saving. You can't save directly to the hard disk by just pressing Control S, but what you can do is display a file save dialog and have the user say, well, I want to save this file here, thank you. And again, because the user's involved in that, it's a safe operation. It's akin to the file open submit button that you can use in an HTML.
That's another security model that the browser is the one that set the precedence on, where you can have input type equals file, and then when you click on that button, it'll pop up a dialog just in a regular HTML page that lets the user select a file they want to upload to the server.
Mm-hmm. So it's a similar model. We also have this thing called isolated storage, which is a special area it's actually on the local hard drive, but it's isolated from the rest of the hard drive, and you can use that as a scratchpad area. It's kind of like Superman cookies will be a way to think about it. It's an area where you can, if you're writing an application and you wanted to do autosave, for instance, well, you couldn't, with the default security permissions, you couldn't do autosave because you can't save to the hard disk, but you can save to this special area of the hard disk called isolated storage. And
so it's an area that just you have access to, and it's sandboxed in that fashion.
Yes.
It's a protected area. And then what a lot of applications do for that is that if they're running and for some reason they crash, and they can recover from it. So the next time you run again, would you still get that same area back so you recover from it?
Yes, it's persistent. It's just like the file system, but it's safe because it's isolated from the rest of the file system.
Okay. So then, if I had an application that conceptually could work within some of these little sandboxed areas, always doing the file open and doing the temporary file storage and stuff like that, it sounds like it'd work pretty well. But chances are, if I didn't write my application trying to think in that framework, which didn't exist ahead of time, there's probably some features I've got in my app that is doing things on the user's behalf that are breaking outside of the sandbox.
Yeah.
If I wanted to continue doing those sort of things, and I didn't want to just have an MSI that they download, I wanted to have this web deployment model, what would that look to the user, and how could I program around it?
So you couldn't program around it yourself, because that would potentially be a security issue, because if you could, from inside your program, you could change the permissions to say, I want more permissions, then the security model kind of falls apart.
You trust me, don't you?
Basically, the best thing you could do in your application is ask the user, do you trust me? And if the user says yes, then basically the answer is, the way they say yes is to go and set up the security policy to say that they trust that particular application more.
So they can use the wizards that get installed by the .NET framework to actually, and it guides them through saying, well, I want to trust code from this particular vendor, or I want to trust this particular executable, or I want to trust code that comes from this website.
They can also use their browser security UI. You can go inside of IE, and if you trust foo.com more than you trust other sites, you can move foo.com from your internet zone to your trusted site zone, for example. And then once it's part of the trusted site zone, it's going to have the ability to do more than what it could do in the internet zone and get a whole new set of permissions. That's another set of UI you could use to do that, to basically control where the code falls into the security categories.
So maybe then if I was an application developer doing this sort of application, maybe I'd want to take and try to detect whether this is the first time the users use my deployed application, and then put up a little tutorial of some sort saying, we're now using deployable thing, these are the benefits you're going to get from it. If you want to gain full access to the application the way it used to run, please do these things, give us your permissions, and you won't see any differences.
I think the ideal way would be to try to do as much as you can inside of the default security policy, because most applications can actually do a lot. And then for the areas of the application where they absolutely need more permission, when the user goes and tries to use that part of the application, you could put up UI there. That would definitely be one option.
So we're kind of getting into some of the areas here where an application developer needs to kind of think through the design of their application, not just do things willy-nilly all over the place,
Yeah.
but actually architect their application in order to be a web deployable, smart application.
Yeah.
What are some of the thought processes you think developers might need to be aware of and be thinking about when they're developing such an application?
Just to list a few, security is definitely one consideration they have to think about. What the application needs to do. Can I live within the default security context? Do I need to be able to do more? If so, how do I factor those things out? Do I need to sign it? Security, what we just talked about, is definitely one major consideration. Code download is definitely another one. So if you were doing a text editing application, for example, and you had a spell checker and a grammar checker and the default part of your text editor, you may want to have those different pieces of the application come down at different times. So for example, when the first time the user goes and they use the spell checker for the first time, that would be when the spell checker would come down for the first time. But you don't want to download just one piece of the spell checker. If the spell checker is like 20 files, you probably want to tell the user with a little bit of UI, hey, the spell checker is coming down, please stand by. But you want to go grab all 20 files of the spell checker so that the user's not continuously getting to the point where they have to wait for that next little piece of the spell checker to come down. That's definitely one major consideration. What other ones would you have, Mark?
Yeah, I think from the point of view of thinking about what this auto deployment model means, that those are certainly the two big things. I mean, you have to think at the point where you're downloading so there's a trade-off. You want to make each assembly as small as possible so that the application kind of trickle feeds onto the client as it's used in the same way that effectively the granularity of web pages. But then you have to trade that off against the user experience, and you don't want the user every time they go and use a new, like every time they pop down a menu in the application, for the application to pause. And so you have to think about what the sensible points at which to start downloading more code are, and how do I package things up so everything to do with this task comes down in one piece, and then when the user moves on to a different task, well, I download all of that, and the user pays an upfront cost for that, but then as they're using the application, they're not constantly getting small pauses.
Mm-hmm. Maybe even like allowing someplace if the user says, hey, I'm going to go out and have dinner right now, you could actually say, hey, let's just download everything.
Yeah.
Like sometimes when I do web pages, a lot of images, I'll have like a page that has all the images and really, 1 by 1 pixels.
Yeah.
And I'll just hit that one page and download all the images.
Yeah.
And that way the rest of the site loads up that much faster.
Yeah. Yeah.
Okay. So you mentioned a little bit about what the future holds for these deployable applications, being able to have some of the deployment and assemblies being automatically maintained by the system. What are some of the other capabilities that we're going to be seeing coming in the future sometime?
Well, I think the biggest thing we're trying to do is, you talk about all the things you have to think about when you're building a deployable application. If you look at a web application, a lot of people don't even realize how easy it is to deploy it, right? Because they just take it for granted. It's kind of what it means to be a web application. And they have to think about it at all. It's just because they're building a web application, they get these characteristics.
Often we refer to it like frictionless,
Yeah, exactly. So we want to get building client apps as close to that as possible. So what that means is we want to make it so that when you build your client apps, if you don't want to, you don't have to think about deployment at all. So you could go out and you could build your application and manage code. And then after that, just like, generally you'll build your application and then you'll go build your MSI project for it, and that'll build your MSI installer, and then that's how you go put that on a CD and you roll it out. That's what you do. But you really didn't think about setup until the very end of the project, and you'd already built your app. And if you wanted to set it up a different way, well, you could use whatever installer technology and do whatever you want. So we want to make it so that you can build an application, and then putting deployment on it is just as easy and just as free. You have an application already built. All you have to do is put it up on a server. You'll give us the information you want about it as part of like a manifest file to say, here's the application, right? Here's the version of the application the user should be using. Here's all the files that make up the application. But all of that would be generated for you essentially by a tool, and then the system takes care of all of the updates. So you build your, the next generation of your app. You put it up on a server, and then you have all your clients point at the server to get the application actually installed. And then whenever you want to update that application, you go update the app on the server, and then all of them automatically do it without having to actually write any code or pay attention to it. And add a lot of features on top of that. So we've talked about this notion of having a spell checker and having the 20 files that make up the spell checkers be treated as one unit and have that automatically be downloaded at the right time. we want to be able to have that specifying which 20 files make up the spell checker be something the developer does at the manifest design time. We also want to make other features work better, right? So you can imagine if you had this, text editor and you first run the text editor, but there's all these other pieces to the text editor, like, the spell checker and the grammar checker that the user's not using right now, but you'd like to be able to use the available bandwidth that they've got that they're not using right now to download those pieces so that when they go use them later, they'll be there for them automatically instead of having to make them wait for when they come down. So we want to be able to have automatically pulling down all the rest of the application in the background while the user's using the app, so that when it's time to go use another piece, if that piece hasn't been downloaded yet, all that is making it a prioritized download. But ideally, it's already been downloaded and making the end user experience better.
So it's similar like a word processor today, nowadays, does its spelling and grammar checking in the background, where it used to be you had to intentionally say, okay, spell check my document now.
Exactly. Yeah. Very much along the same set of lines.
Yeah. So it's just taking the set of features we have now and just making them easier to use and more integrated into Visual Studio, and just so instead of having to make these architectural decisions, it's just kind of there and it just happens, and it's one less thing to think about when you're building your application.
Mm-hmm.
Yeah, we're also looking at how we can make a higher level of administrative controls. So for example, different people may want to run different versions of an application at a different time, right? If you're a salesman and you're traveling, right, you may be over low bandwidth connection. You may not want to be updating the application very frequently, right? You may only want to do it when you're back in the home office 2 months later, whereas someone in the corporate office, they want to update as soon as the newest one's available. So keeping control over who's running what version is something that both the administrator needs to be involved in. So for example, there may be a hot fix, right? There may be this horrible bug in your salesman's order software, right, that it's causing it to screw up the system every time they submit an order. So you want to absolutely have that hot fix applied, so the next time the user logs in, they have to take it, right? So the user has to be involved in that level. On the other hand, where the end user is, in control over, okay, well, I don't have enough bandwidth to download this right now, so I don't want to really apply my update now. So kind of managing that trade-off between the admin being involved in what version the user is using and the user involved in what version they're using is another problem we're trying to tackle in the next release.
So, sounds like what we're doing with the whole smart client application model is pretty exciting, especially from a Win32 programmer's perspective. Finally, getting my hands back on the desktop again and not having to rely on the browser. In just a few words, if you could kind of, explain to the audience why you think they should be paying attention to writing these smart client deployable applications, what would that be?
It's about taking advantage of all the features that are there. It's about making your servers more scalable. So the more work you can do on the client, the more scalable your servers are. It's about an easier programming model. So we've done a lot of work with ASP.NET to make the web server programming model significantly easier and just significantly more productive. But building Windows client applications is still easier. You have to worry less about scalability. You have to worry less about where am I going to store my state between pages? How do I make this transition from this page to this page? So there are all these things that make building a Windows client application easier, and really what we've done is to remove the barriers that make you think twice about doing that today and allow you to really take advantage of all the features that are built into Windows. If you look at all the new things that are in Windows XP, there are some really great features there to be able to build applications that have the deployment characteristics of web-based applications but can still take advantage of all these features on the desktop. I think is a great story.
I think what it boils down to me is that there are just a set of things, especially moving forward, that you're really going to want to be able to do in your applications, like being able to do peer-to-peer, that you're just not going to be able to do on the server, and you're never going to be able to do on the server. The very model mandates the use of a client. So for me, that's really the driving reason, right? There's just so many things that you really just need to be able to do on the client. And right now, it's basically applications have to make this trade-off, right? Do I care about deployment more, or do I care about all these new things that I can do on the client, right, to build actual rich client apps? And what we're going to do is we're going to take that decision away so that you're not going to have to choose between deployment. And then it's just going to be a matter of, do I want the feature set I can use for server apps, or do I want the feature set that I'm going to get for client apps? And for client apps, there's still going to continue to be a large and very interesting set of features that you're only going to be able to do with building client apps.
Just kind of do I want to be the documentation for a game, or do I want to be the game
itself?
Yeah,
exactly.
Okay, well, thanks for joining us. I
Well,
hope
thank you
you
very
get some good insight on exactly what this whole smart client deployable application model is like, and we'll talk more with you, Mark, about how to actually write some of this code.
Okay,
Thanks for
great.
joining us.
Thank you, Robert.
So hopefully that gives you some insight of how a Windows client application can take advantage of some of the capabilities that traditionally only web applications have had with a browser and web server in the way. Stay tuned, and later in the show we'll actually show you some code and some examples of what a deployable application actually looks like and how it functions. So stay tuned. Welcome to the MSDN show. In the last few episodes, we've been talking about various aspects. I was going to say it again. Welcome to the MSDN news. Welcome. Stand by. But before we get into the show, I want to let you know that we hopefully you know now until Microsoft has recently produced new. So stay tuned, and here's talk with Mark. Interoperate with. Well, since the name of the show for. Where was I going with that?
You were golden right up until that moment,
Yeah.
so let me just change shots here.
And other technologies. That's too many technologies.
Cut that. That part will be edited out.
Okay, start over. Welcome back. We're now going to continue our investigation of what a smart client application looks like from this new deployable model that Mark was telling us about earlier. Now, I've got Mark with me again now. He's actually going to be showing me what some of these applications look like, as well as what the code necessary for creating these applications is. Thanks for joining us, Mark.
Hi there again, Robert. So I'm going to show 3-4 demo samples here, and the first sample I'm going to show using the browser as a deployment mechanism, and then we'll go on and show actually writing a Windows application where I dynamically download the majority of the applications.
Okay.
But we'll start with the control in the browser example because it's an interesting example. So you can see here what I've got here is a chart control I conveniently wrote earlier, and this is just embedded in a form. So this is just a little application that shows the chart control running in a Windows form application. So let's have a quick look at that first. And you can see we've got the chart here. You can see it intelligently resizes. I'm using the anchoring and docking features in Windows Forms to actually intelligently resize this form as I change its size. We can come in here and, for instance, because this is just a client application that's running with full trust, I can type in a file name here and actually load that chart data. And you can see this is UK. This is pig iron production, by the way, from 1988 to 1992. And you can see poor old UK isn't doing so great with pig iron production. So we can come in here, we can also click the Customize button and customize a chart. And you can see here I'm actually using the property browser that we have in Visual Studio. That's just a control that you can use at runtime as well. So I'm reusing that control to actually edit the chart here. So for instance, we can change this to 15 and apply it and show there. And you can see this line's got bigger. And you can see I'm also using GDI Plus here, so I've got a nice alpha blend on the chart and those kind of things. So that's a chart running on the local machine. So now let's go and look at the same thing running in the browser. So just before we show it in the browser, let's walk through a couple of things. So you can see my chart control is built up out of 3 pieces here. I've got the chart engine, and this is simply responsible for actually drawing the lines and gets past the graphics object. I then have a chart control here that uses that chart engine to display a chart. And then I have a customization form, which is a form I just showed you. And each of these is in a separate assembly. So when I navigate to this web page, what will happen when I first navigate to the web page is the chart engine and the chart control will be downloaded because they're used immediately. But the customization form isn't actually used until I click on the button. And so the assembly that contains the customization form won't be downloaded until it's actually used until I actually click on that button. So let's start by looking at the HTML page here. So if we scroll down and look at the HTML page, you can see we've got this new form of object tag here. So instead of having a class ID in here, we talked about deployment. One of the important things with deployment is that we don't force you to register things in order to use them anymore. So rather than having a classic com GUID in here, what I've got is an URL that points to the assembly that contains the charting control, followed by a hash, followed by the name of the class within that assembly. And that's what happens is when the web page, when I navigate to the web page, this URL gets passed to the runtime. The runtime goes and downloads the control, creates an instance of it, and hands it back to IE, which then displays it in the browser. So So let's actually just go ahead and view that in the browser, and we'll save those changes. And you can see I'm now navigating to this web page. What's happening in the background is this chart control has been downloaded. So now if we go and look at the download cache here, and there's a little command line utility I can use called GAC-util that allows me to look at the global assembly cache and the download cache. In this case, because I'm downloading things, I'm going to look at the download cache. So this particularly intuitive command line option is how you look at the download cache. There is a little shell extension you can use as well, but it's just easier to use this for the sake of demos. So you can see here's the download cache. I've downloaded the chart engine and the chart control because they're used at the point I refer where I actually create an instance of the control. If we now click on the customization form here, which if you remember is in a separate assembly, you can see I've displayed that now. If we go and look at the download cache again, you can see the customization form has been downloaded at that point. So even with the case where I'm running Windows Forms controls in the browser, we still get this kind of on-demand trickle feed download of the application onto the client. So I could build a control that has a very small amount of code in the piece that's enough to show something to the user, and then just trickle the rest of the control down onto the client as it's needed.
So now, conceptually, that really wasn't, I mean, as far as the web author was concerned, and as far as the user is concerned, that's not that much different than an ActiveX control is today, except that what the primary difference is we didn't see the warning dialog box pop up.
So this goes back to the security, the code access security engine we were talking about earlier. So because it's this the separate policy file that's controlled by the administrator that determines what this control can do, I don't need to pop up the warning dialog anymore because, as we discussed earlier, end users typically don't have enough information or enough understanding to make a sensible decision when that dialog box pops up. So we've moved the decision about what code can and can't run back to the security administrator and the IS administrator who can make those kind of decisions.
Since you as the programmer of that control were realizing how you were going to be deploying in that fashion, you just intentionally made sure you didn't write it so that it had to use something that wasn't supposed to use. So everything it was doing was within the sandbox, per se, and so there was no need to bring that
That's exactly right. So if we can just illustrate this by going to the control, and if I can type, going and trying to load the file we loaded earlier, remember when I was running the control locally, and I hit load, and you can see here that I actually get a system security exception because I'm trying to load a file, and I'm not given the permissions I have, I'm not allowed to load a file. So the security system is proactive in stopping this code from doing things that it's not allowed to do.
So then it's not even that your control didn't have the code to do what it's trying to do. It had the code in it. It was trying to load the file system. It just hadn't yet executed that code.
That's right.
And as soon as it tried executing the code, that's when the CLR said, wait a minute, something's going on here.
Yeah. So I mean, I purposely wrote the control this way to illustrate that point. If I were writing the control for real, what I'd probably do is, as the control initializes, I'd go and see whether I had file IO permission, and if I didn't have that permission, I'd actually just hide those buttons so they didn't even display. So you can go and programmatically find out what permissions you have, and so grey out or hide pieces of your user interface based on that.
Or you could have taken, like we were talking about in the first half of the show, you could have brought up the file open dialog box to allow the user to navigate and locate the file themselves. So you as the application program aren't really doing anything on the hard drive.
That's completely correct. So then the only other thing I was going to show with controls in the browser is if we go to the style sheet here. So this is a style sheet for that web page up on my web server. And if we just change the style sheet and go back and refresh the web page, now you can see that not only has the web page picked up that style change, if you could call pink as the background there stylish, but you can see we listen to ambient property change notification from the browser, and we've actually picked up that style change in the control itself.
So your control is modifying its behavior based upon its surroundings.
Yes, that's correct. So now let's move on from controls in the browser and look at how I write a Windows client application that takes advantage of those same features, that supports automatic code download and automatic update of that code as it's changed on the web server. So again, what I have here is a very simple example. I have my main exe here, which is deployed to my local client machine. It could be deployed as a link in the browser. In this case, I've got it copied to my local client machine. And then I have two assemblies here that contain other forms. So I have first form, which proves that I can't do UI design, and second form, which proves even better that I can't do UI design. These two forms are in separate assemblies. Now, if we look at the main form here and look at the code behind this button, you can see that what I'm doing here is let's move this over so we can see this. I'm using the assembly object that's built into the runtime and calling this method called load from, which is the equivalent of load library in Win32. And here I'm passing it the URL to an assembly up on my web server. So this is very similar to the class ID in the browser. Under the covers, we're using the same technology. And then what I'm doing here is I'm going and getting the first form type out of that assembly. So I know that, because this is a simple example, that firstform.dll contains this class called firstform. So I've got that type back. Now I've got that type, I can create an instance of it here. This is like create object in VB6. I can cast it to be an instance of a form because I know it's a form, and then I can show it. So what I've done here is I've dynamically downloaded an assembly, I've got a type out of that assembly, I've created an instance of it, and then I've started executing code on that class. So if we just build this now. Now what I actually do to illustrate the point here is I actually build that code to a staging server. So let's just go and open up these windows so we can see this. So here I've got my staging server here, and you can see here are those two assemblies that I built. So we'll just cut and paste those. So this is an example of using the .NET framework to do cut and paste deployment to my web server. So now I've copied those. You can see I've copied these to my web server. So now I can actually go back and run my application, and we'll just rebuild. So now I'm running my application. You can see here I've got the load button there. If we go and look at the download cache again, you can see I've got nothing in the download cache at the moment. When we click on the button, what's happening is I'm executing that load from. It's going and dynamically downloaded this form from the web server. And if we go and look at the download cache again, you can see I've got that first form in the download cache. Now, I haven't yet downloaded second form because I haven't made a reference to it. So if we go back here and we look at first form and we look at this button here, you can see that once I've done that initial load from, which is this kind of late-bound model, programming model, thereafter the runtime will automatically chase references for me. When I execute this line of code here and I say new second form.secondForm, the runtime goes to find that class. It looks in the metadata for the first form assembly. It sees that secondForm.secondForm is in the assembly second form and goes to look for that assembly. The first place it looks is on the web server that it downloaded the first form assembly from. It finds it there and then downloads that and executes the code. So if we go back to first form here and click on the button, we can see there's second form. If we go and look at the download cache again, you can see I've got both second form and first form in the download cache. So I can now build this Windows application where it's an exe, it's not running inside the browser. I can dynamically download things from the web server, and as I use more of my application, it trickles down onto the client as it's used. So if we just go back to the form again, close the application down, and we'll go to first form, and we'll just make an update to first form. So if we go to the property grid here and we say, let's say we want this to be obviously a web-enabled application, so let's change the background color of the form to be a web color, say light salmon. There we are. That's obviously a web application now because it's not Windows Grey anymore. So we'll rebuild this, and we'll come here. We can see that we've updated. This is my staging server, so we've rebuilt it to my staging server. I now redeploy it to my web server. I run the application again. There we are. And now what's going to happen when I click on this button is the runtime's going to go and check the version on the web server, see that the version on the web server is newer, and automatically download that and display it. So there we are. You can see we've now got the new version of first form. If we go and look in the download cache, you can see we've got both the old version of first form in case an existing application is still using that, and the new version there in the download cache.
Now, so how is it keeping those two versions then separately of first form?
Well, so what I'm showing here is a logical view of the download cache. The download cache is very like the WinINet cache, in that it's in C Windows WAC assembly. If you go and look in there, it's actually a whole series of subdirectories with made up names, so like 123HZ whatever. And so each time when you download a new version, it gets downloaded into a new place in the download cache, so you can have multiple versions of that same assembly side by side in the download cache.
So then having the two versions out there, so if one of the other applications was still running and hitting on it, it would take and get it in that fashion.
Yes.
But then if you were to launch a brand new application, it would take and use the pre-cached second version.
Yes, that's
that
correct.
you downloaded,
Yes.
so
Yes.
they run that much quicker.
Yes.
So you're not downloading a new version of first form every single time you run.
No, that's completely correct. If I go and close this application down and start it up again, then it would use the version that's already in the cache because the version on the web server hasn't been updated. Okay, so having shown you that, which is really about taking a traditional application and deploying it automatically to the client, it's very exciting, but the application still has a fixed shape. I mean, it was a simple example, so I hard-coded the names, but you can see if I built an application like that, it would really there'd be a fixed number of forms in the application. So what we're going to do now is we're going to take that concept and go a step further, and instead of having the application know what things it's going to load ahead of time, i.e. when I build the application, what I'm actually going to do is I'm going to use a web service to get the list of things that are available to me and populate the client based on the contents of that web service.
So now it's going to be like a programmatic loading rather than a hard-coded loading.
That's right. So what I've got here is I've got a couple of user controls. I've got this customer user control for showing customer details, and I've got an orders user control for showing order details here. Again, I'm going to build these, and if we go back to our cut and paste deployment service again, I've gone to this forms list web service forms directory here. What we're going to do is we're just going to take the form and customer assembly and pop them in here. So now I've deployed my customer form to the web server. If we go to this web service now and say just view this web service, what this web service does, it goes to that forms directory on the web server and just iterates across it, looking for all the assemblies in there. It then opens those assemblies up and uses reflection to determine what classes are available in in those assemblies. So you can see here's my get forms list web service that I've written that's doing this iteration across that forms directory. If we invoke that, and let's make this font a little bigger so we can actually read this easier. You can see that what I've got here returned from the web service is an array of form info objects, and each form info object contains a name and a description, which is enough information to allow me to display user interface on the client without actually having to download anything. And then I've got the name of the assembly, the name of the type within the assembly, the location of the assembly, and an image if there's an image associated with it. So this information is enough information for me to actually go and download that thing and create an instance of it. So if I combine these together, what I can now do is I can write a client application that calls this web service. The web service will go and find all the things that are up on the web server, return that to the client can then build UI based on that. So if you think about something like Outlook, where the Outlook taskbar is maybe populated by the web service, and when you click on an item in that taskbar, it actually then downloads and displays that information on the right-hand side. So rather than me just talking about it, let's actually go and run the application. And it takes a little minute to come up because it's just talking to the web service there. So you can see this has gone and talked to the web service. It's got the name of the form here, and then some description information here that it's built based on the web service. Again, I'm using the anchoring and docking properties in Windows Forms to make this dynamically resized. When I click on this button here, what I'm doing is I'm doing a load from based on the other information on the web service that gives me the assembly back. I'm then creating the type and showing this user control based on that information as well. And you can see there I've actually now gone and downloaded this and displayed it. So if we just close this a second, if we go back to our deployment server again, and this time we'll pick up the order form and deploy this to our web service. Now the next time I run the application, I'll have both the customer order and the order form. So if we refresh the web service here, you can see I've actually gone and found that order form assembly, used reflection to find out the information inside it, and then built it into this web service. Again, we run the application. It'll go and talk to the web service and dynamically configure itself based on the results of that web service. And there you can see we've got both customers form and an orders form there as well. So you can see now we can start to build applications that not only auto-deploy themselves and have those same deployment characteristics as web-based applications, but we can also start to think about combining web services with this feature to build Windows applications that are personalized. So for instance, you can imagine taking this application and having the user identify themselves either via passport or some other authentication mechanism, and based on that determine what tasks they should be allowed to do and dynamically download the code associated with those tasks. So you can actually start to build Windows applications which have another interesting characteristic of web applications, which is personalization. So I'll go on and show that now. So, and this is the application I talked about. So this is a business application where there are a set of modules built into it, and depending who logs onto it, they get a different set of things, and that code is dynamically downloaded. So rather than having to build a monolithic application and ship it all to the client so that somebody who's a manager and somebody that's a salesperson can use those different tasks, it's just a shell, and the pieces get dynamically downloaded into the shell based on who logs onto it. So if I log on as a sales guy, I get the customers module, but if I log in as a manager, I get the customers module and the people management module. So let's go ahead and log in, and we'll type in John Smith. And you can see now that we've logged in as John Smith, we get his desktop here, which gives him his account information, and we get these options at the top here: customers, purchasing, and travel. Each of these is a little assembly that's been dynamically downloaded from the web server. What happens when John Smith logs in, it goes and talks to a SQL server on the back end and says, what are the things that John Smith is allowed to do? Well, he's allowed to manage customers, he's allowed to purchase things, he's allowed to book his own travel. It returns that in a web service. We then go and dynamically download these assemblies into the toolbar based on the results of that web service. So if we click on customers now, again what's happened is this add-in here has been dynamically downloaded. So the customer's task has been dynamically downloaded onto the client, so I can use it. And if we click on the little toolbar item down here, we can navigate to activities, for instance. So this application, because it's a Windows client application, is integrated into the desktop.
So that's something you couldn't do in a standard web application, because you were just within the frame of the browser itself. Now you really are a full-blown desktop application that can use all the Windows XP features and capabilities.
Yes, that's completely correct. And what I'm actually doing here, this application is just showing my accounts and the details for each of my customers. What's happening is, as I navigate these pages, we're talking to a web service, a customer information web service, that is downloading this information. So I've exposed all of my back-end services as a web service, and then Windows Forms and Visual Studio.net makes it really easy to build smart client applications that communicate with web services.
So then what essentially showing is a full-blown application that's touching all the aspects of that. You got smart client application going on. You've got web services going on, which are part of .NET. You've got some web browser sorts of things going on as well. That's so you're making use of, it's kind of almost like the right tool for the right job all the way across.
Yes.
Yeah, that's exciting.
That's exactly right.
Yeah.
And then the other thing I can do with this, because this is a smart client application, I can actually make it available offline. Now what happens when I go offline in this application, because it's a small set of data, it's very easy to pull that from the back end by talking to those same web services, getting the information as XML documents, and using isolated storage, which we talked about earlier, to actually store those as XML documents. Then when I click on work offline here, instead of going back and talking to the web service, what I'm actually doing is I've redirected the application to isolated storage. And so when I select PepsiCo and click details, I've actually just gone and loaded this as an XML document out of isolated storage.
How much space is available in that isolated storage?
For intranet applications, there isn't a quota. So if you're writing an intranet application, it's really the physical size of the hard disk. For internet applications, there is a quota, and I think it's maybe 10 megabytes per application.
Still a fairly big
still
size.
fairly, but again, that's the cap on that storage for internet applications is controlled by the administrator, so the administrator can make sure that you can't write a bad application that goes and sucks up all your hard disk space. So if we just go and work online again, and we've gone back online, if I made any updates at this point, they'd be fed to, they'd use that same set of web services to feed the changes that have been made back to the back.
Now, would that be something that the application developer would have to take and write into their app to synchronize the local storage with the web storage?
That's right. So what I've done in this case is I've used ADO.NET datasets, and ADO.NET datasets actually record the changes that are made as you make them. So what the application does is it records all of the changes to a dataset, and because the thing that I pass between the client and the server when I'm online is a dataset, it makes it very easy to add in that offline online synchronization capability, because I've actually recorded the changes in the dataset, taking advantage of that. Now in this scenario that works very well because this is John Smith's clients and John Smith's activities, so I'm not having to do a lot of reconciliation work. If I take my laptop on the road and I add new orders or I update customer information, I wouldn't be having to do a lot of reconciliation with the back end because it's my set of information. Obviously if you were writing an application that had lots of concurrent updates going on at the same time, this maybe wouldn't be quite such a good application architecture, because you'd have to be doing a lot more reconciliation when it's reconnected.
Okay.
But and so let's just go and show one more feature here. So if we over here we have our slightly less whizzy looking administration console. So what I can do in here is I can come in and I can load the options for John Smith, and let's say John's a great guy and it's about time he took on some more responsibility, and we're going to give him some people to manage. So I can just come into the admin tool here and say, well, John needs to have the people add in. I can save this. I can go back to my application here, I can log off, I can log in again, and now I've logged back on, and you can see not only do I have customers and purchase and travel, but I also have people, because what's happened is I've gone, my logon web service has gone back, seen that John Smith has got this new task he's allowed to do, and automatically downloaded the code for that.
So it's really not something that was being forced to be loaded all the time by this application.
Yes,
who's dynamically figuring out options based upon database settings.
Yes. So it really shows that you can build these smart client applications that integrate with the desktop, but also have these very nice auto deployment features. If we were to go and update customers, we'd automatically see that update next time we log on. I can personalize the application based on a user role or based on the particular things the user is allowed to do. So it really begins to give you the best of both worlds, all the things that are great about building web-based UI and all the things that are great about building Windows UI.
Now, this application isn't that different than what a web-based application would be. I mean, granted, we showed a little bit more integration with the Windows XP shell and having the taskbar stuff you click on, stuff like that. But let's still think about a traditional Windows application like, Excel or Word. Would those applications work using this smart client deployable model like this?
Yes, I mean, obviously you'd have to do, if you had an existing application like that, you'd have to do work to re-engineer it. For a start, you'd have to move to using managed code, and then you'd have to do this work we were talking about earlier, which is thinking about, okay, if I'm going to build an application where parts of the application can be dynamically downloaded or dynamically updated, how do I architect that application? Where do I put the barriers? What are the tasks? How do I put those tasks together into a single assembly? So, for instance, when I click on customers in this app, it pulls down all of the assemblies for customer. And those are the kind of things you'd have to think about.
Like one of the benefits you'd get, though, from that is, let's say you were doing a version of Word that had spelling checking in it. Let's say spelling checking is coming down as a component. Then the developers was able to create the grammar checker, but that wasn't part of the version that you had downloaded. But part of your download was including a let's find out what components are available on the web, and your subscription rating you had with the company allowed you to download things dynamic like that. Suddenly your application, which never had grammar checking before, suddenly now has grammar checking.
Yes, exactly. That's a really good analogy.
That can be pretty exciting. And since it's using web services and all that whole model, you almost could get into like a subscription model, where you as a user
yes.
could buy a static version of an application and pay $49.95 on it, or if you wanted to get a dynamic web update model, pay another $10 or something like that, and then you'd get a year or 2 years worth of automatic downloads on stuff.
Yeah, I think that model would fit in really nicely with the things that we got in the .NET framework.
Yeah, I know. Like right now, I've got a few applications that I run that has on their help menu as a check web for updates,
Yes.
and I do check web for updates, and it goes to a web page, and the web page says yes, you have a new version you download. Click here to download, and I do all that sort of stuff there.
All of that thing would be seamless. So it would just be there are new updates available. Do you want to install them? Yes. Then you can take advantage of them, and that would be it.
Another thing I noticed that in all of that different ways of looking at how to run these smart client applications with web downloads, we only saw one warning box.
Yes.
And that was warning box on that file load thing.
Yes.
I mean, all the rest of it was there were no alert boxes, no cautionary warnings, no do you give permission sorts of things like that, which I know since I quite often take a lot of questions and people writing web pages and stuff, they're constantly saying, how can I not have this box come up? How can I get around this? I hate having these things come, because anytime the user is has a decision they need to make, quite often they're confused by it.
Yes.
And they either I can't handle it, and they walk away from it or whatever.
Yeah.
Forms I got to fill out and stuff like that. And I see this as being a very, very smarter way of doing something like that.
Yes. Yeah. I mean, that's one of the great things about the code access security model we have. It allows you to move away from having to prompt the user to make those kinds of decisions.
Now, in talking with the developer communities out there and stuff like that, what are some of the main questions people ask you about this new model?
Well, so the questions I get are, when can we have a copy of this sample application?
Okay, so let's answer that one.
I'm trying to make time. I hope that definitely in the next month. We want to have it up on one of our websites by the PDC, so that people can get their hands on it. And then his questions really about, how do I understand more about the security model? How do I understand more about how I design these kind of applications? Those are the kind of questions that we get. So hopefully we've answered some of those things today.
And where can they go for more information?
So the documentation that comes with Visual Studio and the .NET Framework are a really great place to start if you want to understand the nuts and bolts. There's some information on MSDN. There's information on the .NET website that we run. And we're in the process of putting together a series of 3 or 4 white papers that describe this in more detail and help people really understand how they can build these applications.
Now, are you going to be at the PDC coming up here in October?
Yes, we've got a series of talks at the PDC where we'll be covering a number of aspects of Windows Forms, but one of the big things we'll be talking about is this, because it's for me, this is the most exciting thing about Windows Forms, is it enables this new style of application. It really solves a problem that people have today when they're building Windows applications. Well, I want to build Windows client applications. I want to take advantage of those features. But
I hate living within the browser.
Yeah, that's right, exactly.
Yeah.
But how do I get around the deployment issues that I'm faced? How do I roll this out to 5,000 desktops in a seamless manner? And I think we've really addressed that. I mean, and as we move forward, it will just get better and better and better.
Okay. So do you have any closing words for our audience about what they should be paying attention to?
Pay attention to this. Look out for the white papers and articles. Start thinking about how you'd build your applications to take advantage of these features.
Okay, and I'll make sure I include links on the bottom of the transcript to some of the different sites you're talking about. And if you happen to get the version of this application out by the time the show's done, I'll include a link to that as
that
well.
would be great. That would be great. Thanks very much.
Thanks, Mark.
Thank you.
So hopefully Mark answered some of your questions about exactly what is this new smart client deployable application model. What does it look like? How does it affect your development, perhaps, and how can you maybe utilize it to finally, break outside of the barriers of a standard web browser application? And if you, by chance, you happen to come to the October PDC, you'll get a chance to meet Mark in some of the talks that he's going to be doing, as well as getting a chance to see a live version of the .NET show with a live studio audience that you can ask questions of. And hopefully maybe Mark will be one of the guests I have on that show as well. So stay tuned. This show's not quite over, and we'll catch you later.
The ability to read books on desktop and portable electronic devices is making strong headway at Microsoft. With me today is Janine Harrison. She is a Group Program Manager for the Microsoft Reader team.
That's right.
Janine, welcome.
Thank you for having me.
So what is Microsoft Reader?
Microsoft Reader is the software that we use to display books online. And it has features that allow you to make it very clear to read the text, very readable. And then we've added extra things to go beyond the book, like annotations and lookup and dictionaries.
So what do you do for the group?
I'm the Group Program Manager, so my job is to work with my team of program managers, and we spec out the features and the functions for the Microsoft Reader. Then we work with the developers and the testers to actually get the software developed and get it ready to ship.
So what are some latest projects or endeavors you're working on in your team?
Well, right now we're actually very close to the ship of Microsoft Reader 2.1.
Okay.
That will be shipping in October. And we'll have a brand new version up. New features include, well, we did a big work for accessibility. So in this particular release, we wanted to make it so that people who couldn't see or who were blind would be able to have the text read to them and have full keyboard navigation abilities, because the Microsoft Reader, due to security, can't work with a screen reader. So we spent a lot of time trying to make it so that any person has access to the text.
So Microsoft Reader plays a big part in the accessibility world, people that are accessibly challenged.
I think we've been disappointing so far. So with this release, our desire is to make it so that anyone has access to the content with no delays. The big thing has been that if you were a blind person or you had low vision, you had to wait as much as 18 months to 2 years to hopefully get an audio version of a book available. This way, we bring you the same text that you or I get to read online. They get it at the same time that you and I do, and they get to hear it and have it read to them.
What are some other advantages of Microsoft Reader and the e-books that are coming out these days?
Well, I think the things we're very close with our ClearType technology to being able to read on screen with the same clarity as what you would on a piece of paper. So we're very close to being the same as if you were reading a book. And we've added the things that I call going beyond the book. And that really relates to what we call active reading, or the reading of annotations, being able to add highlights. You can do searches and lookups. A school that I know, the teacher had given her students an assignment. They had to search through Alice in Wonderland, find every instance of when the white rabbit appeared, find the first instance of when the white rabbit appeared. And if you were doing that in a book, on paper, you know, it's much more time consuming. Whereas online, you actually just do a lookup, find next, it tells you. One of my favorites is Beowulf. I happen to really like it. But the Old English is really hard to figure out what the words mean. You can have an Old English dictionary. You don't know what the word is. You do a find in a dictionary. It shows you the word. You can jump from there to other associated words. So those are some of the things. You could also, if you were doing a paper, you could have multiple books open, have references, have text notes about the paper, pull that together into Word or some other processor, and then write your paper.
It's fascinating. Wow. So how long have you been with this group, and what other jobs have you had at Microsoft?
I joined this group a little over a year ago, right before they shipped version 1.5. So I've since shipped 1.5, 1.51, 2.0, and 2.1.
Wow.
We've had a pretty busy year.
It's a big history.
A very busy group. Before that, I worked in Microsoft Exchange. I've always been what you would call a systems person. I've worked in Exchange and shipped developer work there. I've worked in Microsoft Back Office. I was the second employee in Microsoft Back Office and created and shipped multiple versions of Microsoft Back Office. Before then, I was really fortunate. I worked on developer things. I did the Platform SDK. So the first time you saw the Platform SDK up on MSDN, my group was working with the MSDN team to put that there.
Really?
And then I worked on, you know, everything from OS2 to Windows to a project we called Cairo that never shipped, unfortunately. But it's cool to see technology from it shipping in the company now, and just stayed on the side of the house, either helping developers or bringing new features on the server side and the operating system side.
So it sounds like you've been here several years and had a chance to really migrate and see a lot of different areas of the company.
Yeah, I feel really fortunate. I actually just celebrated my 13th anniversary with the company.
Wow. Great.
And I'm fortunate, too. My original hiring manager still works here.
Really?
I have quite a few friends who are still here. I, in fact, congratulated about 4 or 5 friends who joined at the same time. It's been a great ride. It's a great company.
What do you like best about working for Microsoft?
I think I know obviously it's the freedom. It's the freedom that keeps me here, the challenges. I feel at Microsoft you're very free to make decisions, to do what you think is the right thing for your customers. It's, you know, the decisions aren't made at the top. Decisions are made at the lowest down level that they can be, and you're very involved in them. And I think that sense of freedom. And then obviously the fact that we've gone through so many changes in the computer industry. We've had look at, we've gone so far from where I used to have a 286 with 6 megabytes of memory, and we thought that was a big machine, to today where we're shipping with XP, and there's so many things that have changed. I mean, if you look at my history, I worked on developer things, I worked on operating system things, server things, and wow, I just had the opportunity to go work on a client-side version that can have huge impacts into the accessibility community, help a blind person get a book in Braille or read to them. It's it's the changes, the challenges, and it's the fact that we have all those opportunities.
Yeah, it just spans multiple areas.
Yeah.
So what sort of things do you like to do outside of work?
I have to admit, over the last few years, the biggest thing I do outside of work is spend time with my family. I have a 5.5-year-old daughter and a 3.5-year-old son, and I spend most of my time outside of work with them. I'm a voracious reader. I was up last night till like 12:30 or something reading a new book.
Yeah.
And, I find that great fun. I'm also a huge Mariner fan, so this season has been fantastic, and I'm really looking forward to the playoffs.
That's great.
So, I spend it those ways. I used to do a lot more, but with my kids, no, they take up most of my time.
Yeah. Are they interested in technology or online books or anything like that?
Yeah, the funny thing is my husband kind of cringes, but my daughter says she wants to come to work at Microsoft.
Yeah?
With Mommy.
How old is she?
She's 5.5. So he's a little terrified that in 20 years I'll still be here and she will be coming to work with me. She used to send me email when she was about 3. She would type on the keyboard with her dad.
Wow.
My son is really into it. They both really like the Magic School Bus computer games and those. I think they're both really into it. My daughter was actually an early reader. She started reading at age 3. So I would say probably the love of reading runs in the family.
Sounds like it.
I think they'll be quite whizzes. They can move around a computer with no problem already.
Yeah, that's great. So what are some things you'd like to see in the future? Where would you like to see this technology, a Microsoft Reader and the whole e-books and Pocket PC? Where would you like to see that go? What are some things you think problems that could solve in the future?
Well, I think the first is we know today in Microsoft Reader ways to make it so that it's much easier to read text on screen. And a great thing that we can do for the company and for our customers is to bring that technology so that it's available to everybody, whether it's an Outlook email message, whether you're reading a Word document, you're reading a web page. We can bring that to you so that text now is more readable. If you're about over a page, you're going to print it. Right. Because it's just too hard to read the text on screen. It's not clear enough. What we find is people don't leave enough spacing, and it makes such a huge difference to your reading and even your comprehension. So I think the first thing you'll see from us is we'll be trying to spread that technology throughout more mainstream applications and not just into books. We concentrated first on books. For Microsoft Reader itself, I'd like to be able to, people aren't going to want to read necessarily on straight desktop. It's just not that interesting. It's not a position you read a book in.
Right.
But we are able to do with the CE devices, and of course with embedded NT coming out later, we'll be able to go to other devices. There are these really great, in fact, I was going to bring one today, but the web pads, it's a 10-inch, weighs 2 pounds, has about a 6 or 7 hour battery life, and you can download music, you can do video, you can search the web, you could read a book. And I think you'll start to see a merging of the content, so you won't have, like today you have the Microsoft Reader, you have Microsoft Windows Media Player, you have Explorer, and I don't think that'll stay that way. I think in 5 years you'll see something where technology is merged. The content you have, why do I care if it's music versus a book? I might want to have that book and have someone who's reading the book in a human voice and watch that being read on the page. I might want to hear a song and look at the lyrics. I might want to see a video and able to bring up some other content information about the video. I shouldn't have to go through multiple applications in order to do that. So I think you'll see us do that.
A lot of customization available.
Yeah, I think you'll start to see the merging of content into types I'm not even sure we understand today. And then we'll bring more of it, I think, to the mainstream instead of keeping it just in something like the Microsoft Reader.
Right. Well, that's great. Janine, thanks for joining me today. It's been great.
Oh, you're welcome. Thank you.
Well, that brings us to the end of another episode of the .NET Show. Hopefully you learned some ways that you can take and write a traditional Windows application that's still utilizing some of the great capabilities that Windows XP and other Windows operating systems has, as well as takes advantage of some of the great capabilities that we've gotten used to in a web application.
And be sure to join us at the PDC, where we'll film the next .NET Show in front of a live studio audience.
And until then, we'll see you on the web.